A law in chemistry, or in science more generally, is simply a mathematical statement about the behaviour of matter. For the laws that we'll see in the IB chemistry course, we can consider them to be 100% accurate all of the time. Of course, that's not to say that at some point in the future, in light of new evidence, we could prove laws wrong, but for now, we use them with a very high degree of confidence. Because laws are mathematical statements, they describe the behaviour of matter, but they don't actually help explain it. So let's have a look at a few common examples we might see in the IB chemistry course. We've got the law of the conservation of mass, Hess's law, equilibrium law, perhaps Avogadro's law, and a bunch of other gas laws that we'll see. For a bit of fun, here are the formulas that define those laws. And it's probably worth noting that often we will use the formulas that you see in front of you, but sometimes in IB chemistry we'll actually describe the law in words instead of using a formula. For example, the law of conservation of mass, you're never going to see that formula. But you do need to understand what the law is telling us. For a bit of extra bonus fun, you might want to consider which of the 7 core concepts identified by cohesive chemistry are related to laws. Here are the 7 core concepts. And particularly if you do physics, you might be able to tie some of these to laws. You can pause the video here and have a think about it if you want. And of course, if you don't want, I'll tell you the answers. So electrostatic forces and potential energy are both related to Coulomb's law. Kinetic energy is derived from Newton's second law. The conservation of mass and energy is described by the first law of thermodynamics, as well as using Einstein's famous E equals mc squared. And finally, entropy is described by both the second and third law of thermodynamics. Exciting stuff. And yeah, that's probably it for laws. Hopefully you found this video of some help.